In this tutorial I'm going to talk about instantiating components in VHDL. It's a very nice feature of VHDL which allows us to create hierarchical design. That means we can encapsulate some circuit into an entity, and then we can instantiate that entity into a bigger design. And this way hiding the complexity within many components that we can combine together and connect with wires. So let's start Xilinx. This time around I'm using version 14.1 of Xilinx tools, but more or less what I'm talking about in this tutorial applies pretty much to all recent and probably quite a few of the next feature of Xilinx. They're quite similar with each other, so it should be quite fine. So we are starting the Xilinx tool. The first thing we need to do is to create a project. So we click on New Project and we wait for the wizard to pop up a window. In here you can select the directory where we want to save the project. I'm just going to leave the existing directory, and then we give a name to the project. Since I'm talking about component instantiations, let's just call it like that. Component instantiations. We want to write VHDL, so it's an HDL file at the top level. And if you want for some of your projects, you can also write a description here, just so that you know what the project is about. Click Next. Here, in general, you need to specify the parameters for the FPGA board that you're using and for the simulation. In our case, in my case, I'm using a Nexus 3 board, and these are parameters for the Nexus 3 board. But since this tutorial is quite generic, we're not going to implement the examples in the board, then pretty much any parameters in here would be fine. And then we click Next. Here it's a short description of the parameters used for the project, and then I click on Finish. So now the first component that we are going to create, it's an AND gate. It's a very simple, a basic building block of digital electronic designs. And I'm going to create an entity for this AND gate. So the AND gate looks something like this. Here we can see the symbol, which is traditionally used in schematics. It has a truth table like this, so it has two inputs, A and B, and the output O. And now whenever the inputs, whenever one of the inputs is a 0, then the output is a 0, and when both inputs are 1, then the output is a 1. So in our case, we are going to create an entity for this component. So we're going to encapsulate it into a bigger component. And that entity is going to have A and B as inputs and O as an output. Generally, when we create entities, we create more logic. But for this simple example, we're just basically going to put only an AND gate into the component itself. So, in order to create a new file, one simple way to do it is to click on this icon in here, which is called New Source. Click on it, then we are supposed to select the type of file that we want to create. We want to create a VHDL file, so we select VHDL module. We are supposed to give it a name. Let's call it AND gate. The extension is kind of optional, so if we don't write it, it's going to be put automatically for us. And the file is going to be added to the project automatically if we tick in here. We click Next. Here we can say the name of the architecture. We can, for example, use circuit. The name should kind of reflect the kind of implementation you have for that component. Now we need to give the inputs and the outputs. So we have an input A, an input B, and an output O. Here we can select the direction. So for the output, we are going to select out. And then I can say next. This is a summary of the component that we are creating. As you can see, it has A and B as inputs and then O as an output. And then we click finish. So now the new component it's created. So we have an entity for it. So basically what the wizard did was to create an entity for it, and then in here in the architecture we can say what's inside that component. In our case we said that we want to implement an AND gate, so it's going to say O, it's going to be assigned the value of A and B. Now we save. We can see that when we save, the tool is going to check if I made any spelling errors, any mistakes, syntax errors. So for example, if I forget the semicolon and I save, I'm going to get a warning. Actually, in this case, it's a syntax error. And it tells me that close to this keyword there is an error. In our case, it's the semicolon missing. So now this is the basic component that I'm going to use to create a larger circuit. I'm going to instantiate this component twice. So the component that I thought to create was a 3-input AND gate. We can achieve that very simple by chaining 2 AND gates together. So in the first AND gate I'm going to have the first 2 inputs A and B. The result of this one is going to be sent to the second AND gate that is going to be ANDed with C. And the output is going to give us the output of the 3-input AND gate. From the VHDL point of view, we can see this as instantiating the AND gate component twice. Once in here and once in here. The output of the first AND gate is going to be connected to the input of the second with the signal called TMP. The AND gate component, as you remember, had 2 inputs, A and B, and an output O. And these signals are going to be connected to the output signals. So for example, the O is going to be connected to an output signal, to an outside signal called TMP. But we are going to see very quickly how this is done. So first let's create a component called let's create a new source. You can also create a new source by right-clicking in this window and selecting new source. It's again a VHDL module. We're going to call it AND gate 3 inputs. Next, the inputs are going to be A, B, and C, and the output is going to be O. I'm going to specify that it's an output in here. And that's about it. I just say next and finish. So now I have the new component. At this point there is nothing said about the contents of the component. There is only the interface of the component given by the port map, by the ports. We can see ABC inputs and O as an output, but there is no functionality associated with that component yet. So more or less what we need to do is to instantiate the two AND gates and then connect them together like seen here. So let's see, in order to instantiate one AND gate, the easiest way to do it is to select the component that I want to instantiate, this AND gate, go to Design Utilities, and then click on View VHDL Instantiation Template. It asks me if I want to save the current file. I say yes. So this is the instantiation template. More or less what I do with this one is to copy and paste in my design. So I'm selecting the text that I want to copy, then I press Ctrl+C. And then I go back to the file where I want to instantiate my component. So what do we see in here? We see that we have some kind of name for the component. I usually like to call it something like the component name and _1, but saying that is the first instance of that component. Then there are several ways to instantiate components. In the old days, we could use the in the old days, meaning VHDL 87, an older version of VHDL, you're supposed to put this part before the begin. So you're supposed to put it in here, and then the other part in here. But since VHDL 93, we can only use this part directly. So it's a bit easier. In order to be able to find the AND gate, we have to specify where it is. So we have to specify first of all that it's an entity, and it's found in the work library, and it has the name AND gate. You can see the entities that are in the work library by going here to libraries, then looking in work. So whenever you add a new component in your project, a new entity in your project, is going to be by default added to the work library. And then later on you can instantiate that component in other entities. Okay. I usually like to put the port map on the next line, but this is just a matter of taste. And now the job that we have to do is to connect the internal signals of our AND gate component to the external signals from the circuit that we are creating. So we can see that in, and we can refer to this picture more or less. So this internal signal from the AND gate component is going to be connected to the external signal. In this case, they have the same name, A. And the B, internal B signal is going to be connected to B, and the O is going to be connected to TMP. Let's do that. A is connected to A, B is connected to B, and O is connected to TMP. Now, another way to instantiate the component is by going to the file where the component is declared, copying the entity declaration with Ctrl+C, and going to the place where we want to instantiate it and pasting it with Ctrl+V. And then to do the component instantiation, we would have to do some editing in place. So it's a matter of taste if you prefer to use the instantiation template that is provided by the Xilinx tool, or if you want to do it by hand. So let's do it by hand this time. And gate 2 is the second instance. Again, we find it in the work library. So we say work AND gate. We have to erase the ISE. Here we have to say port map. And now we have to erase these lines and use the arrow to the right. Let's do like this for now. Then we're going to close the parentheses. This last line with the end gate we are erasing as well. So you see we kind of ended up with the same structure like in here. And now the signal A is supposed to be connected. Let's look in our drawing again. Now we're instantiating this one. So the signal A is supposed to be connected to the external wire called TMP. Signal B is going to be connected to C, and signal O with O. A is connected to TMP, B is connected to C, and O is connected to O. Now, as we notice from this drawing, A, B, C, and O are signals that are from the interface of the AND gate with 3 inputs. So those are declared in the entity declaration of this component. But we have one internal signal called TMP, which is not declared yet. We have to declare it as well. And we do that inside the architecture. It's an internal signal to this component, so everything that is inside the architecture, it's declared in here between the line with the architecture keyword and begin. So it's a signal. It's called TMP. It's a single wire, so it's called it's of the type standard logic. And in this moment, we've managed to instantiate our AND gate twice. And the first AND gate is connected to inputs A, B, as the output TMP, and the second one is connected to the output from the first gate TMP, C, and the output is O. So we described exactly what we have in this drawing down here. Okay, let's try to make sure that this design is correct. So let's try to synthesize. You notice that since the AND gate 3 input component, this one, has been using the AND gate as a subcomponent, we got this plus sign, so we can see all the components included in our main component. And then if we double click, we can see the contents of the subcomponents as well. Now to synthesize, we just have to select the top level, which is this one, and then click on the synthesis button. It's going to take a few seconds. And then it's going to tell us that everything is okay. So if we get a green circle, everything is okay. We can also view the RTL schematic. So the schematic built with gates. So if we double click on this, it gives us this wizard. We can see the top level, or you can see some internal components. But let's look at the top level. We are going to see the design from the top. Say OK. This is the black box of the AND gate with 3 inputs. It more or less corresponds to this outer box. And if we look inside this component, we see the other 2 boxes of the AND gates. So you can notice that this drawing looks very similar to the one that we have down here. And if we double click even further, we can even see what's inside these components. Let's zoom out a bit. So we can actually see even at the gate level how it looks. Okay, so now we've managed to instantiate the AND gate twice and created a 3-input AND gate. Let's try to consider other options, other situations that we might be in. So for example, what if we want to create a 2-input AND gate, but the inputs are not 1 bit like in our case, but they are 8 bits. What would we do in that case? So let's create in a new component. Again, it's a VHDL module, and let's call it this time an AND gate 8-bit, for example. So every input is going to have 8 bits instead of 1 bit as until now. Click on next. The port names are the same, so we still have A, B, and O. But this time around we are going to use 8 bits per port. So in this case we need to specify that we are using a bus. A bus is a collection of wires. In our case we're going to have 8 wires. And the most significant bit is going to have number 7 and the least significant is going to have number 0. We do the same for B, 7 down to 0. And for O, first of all, it's an output bus, and again 7 down to 0. Go next, finish. So here we have the new interface for this new component that we've created. Now you notice that the type of this ports, it's standard logic vector, and in our case, since we have 8 inputs from 7 down to 0. So this is still an AND gate, and actually the contents of the architecture is the same. So we're going to have O, it's equal to A and B. The only difference now is that A, B, and O are 8 bits. And for every bit we're going to do an AND operation. So A0 and B0 are going to be assigned to O0, A1 and B1 are going to be assigned to the O1, and so on. So we save it. If you want to make sure that everything is fine, then you can also synthesize it just in case. Sorry, there is a slight thing that I should mention in here. So right now when I'm synthesizing, actually I'm not synthesizing this new component that I just created. I'm still synthesizing the top level component, which is called AND gate 3 inputs. To synthesize this newly created component, I have to make it top level. So first I select it, and then I create. Then I click on this icon called set module as top, and then we say yes. And now you can see this symbol has shown next to the component that I just created. And now I get synthesis button for this component. So let's try to synthesize it and see what happens. So synthesis went smoothly. So now if I want to create a 3-input AND gate where every port has 8 bits, we would use the same procedure like before. So let's just reuse the old file that we had. So this is the old file that we had. Basically, the internal stuff is going to be the same. So the only thing that is going to change for the new component is the name of the entity and is the types for the input and output ports. So let's create a new component and then copy and paste the contents from here. Create a new component, VHDL module. Let's call this one and gate 3 inputs 8 bits. So it's 8 bit per port. Next. So we have inputs A, B, C, and O. The O is the only output. And they're all 8-bit buses. From 7 down to 0. In case we make any mistake in that template, we can always modify it by hand. So if I would have forgotten, for example, to say it's an output in here and I would have said an input, I can always edit the text. So I said that the internals are basically the same. I'm still dealing with the same picture like in here. The only difference is that instead of having 1 bit for the inputs, I have 8 bits. But the rest is the same. So that means that I can go to the other component that I had with 1 bit. Then if I copy what I had inside the architecture, let's copy this part, Control C. We go to the new component with the 8-bit per input and then say Control V. There is one thing that is missing at this point, is the TMP signal. When we are dealing with the 1-bit component, TMP signal was the type standard logic. Now it's going to be of the type standard logic vector 7 down to 0. So now when I press the save, I notice that there are no syntax errors. And let's try to synthesize this component and make sure that it's correct. So again, we need to select it, set it as top module, and now we can synthesize it. Okay, it looks like we have even an error. So let's see what the error is. Oh, yeah. So we've instantiated the wrong component. So in the new design, we are supposed to instantiate the AND gate with 8 bits. So we're supposed to instantiate this component rather than the AND gate with 1 bit per input. So we have to update the name. But the ports are the same. So let's try again, synthesize. Oops. One more error. I typed only bit instead of 8 bits. So usually when you write VHDL, it's an iterative process. You might mistype something, so you need to synthesize, and then if you get any warnings or errors, you can get back and fix it. So now we've created a new circuit. Then if we look to the RTL schematic, Again, we look from the top level. We have AND gate 3 input 8 bits is the component that we created. Now we see that every input has 8 bits for the indexes from 7 down to 0. Every input and output. If we look inside it, we're going to see that we have the 2 AND gates. If we look even inside it, we're going to see the actual gates. But now we've created an 8-bit per input component. Before we had a 1-bit per input. But what if we're dealing with a situation when we have to have a varied amount of bits? So let's say we have to have some AND gates where the inputs are 2 bits, some AND gates where the inputs are 7 bits, some AND gates where the inputs are 22 bits. It's not very practical to create one component for every possible variation in the number of bits for the input. It would be nice to have some kind of parameter that we can easily set when we instantiate a component. And actually VHDL offers us this option. So we can have a parameter called the generic where we can specify the number of bits. Obviously, the parameters can be anything. So it could be integers, it could be standard logic vectors, it could be any type of parameters that you can think of. In our case, since we're interested in describing an AND gate with a variable number of input bits, we're going to have a parameter called n, for example, where we specify the number of bits per gate. So let's try to create a new component. Again, a VHDL module. And this time we're going to call it AND gate n bit, which means that it can have variable number of bits. It's going to have the same usual inputs. And in this particular case, we're not going to specify. Well, we can specify that there is a bus, but the thing is that we'll have to change this later. So let's say it's still 7 down to 0 bus. Then next. Finish. So this component so far looks like the previous component that had only 8 bits per input. Now if I add this other field called generic, I can say let's call it n, it's an integer. And for parameters, we also need to give a default value. So let's say that this default value is 8. So in here, to assign a value, we use this symbol, the column and equal. And now instead of saying 7 down to 0, we are going to say n down to 0. So this is where the parameter comes in. And the nice part now is that this parameter is going to be modifiable when we instantiate the component itself. So let's see how would the actual AND gate look like. The contents is the same actually. O, it's A and B. So we don't have any syntax errors. we can eventually even synthesize the component just to make sure that it's correctly created. So we select it, we set it as a top module, say yes in here, and then we synthesize. And as you see, there is no problems, and if we look in the schematics, we're going to see our component, which is basically just an AND gate with 2 inputs and 1 output. Okay, so actually, if we are to have 8 bits, we have to go from 7 down to 0. So in this particular case, we're supposed to put in here n minus 1 down to 0, n minus 1 down to 0, n minus 1 down to 0, to be politically correct. Okay, so now we have our generic component. Now let's try to create a 3-bit gate where we instantiate this component instead. The 3-input gate where we instantiate this component instead. Make another component, and we call this one AND gate 3 inputs. And then we can say 12-bit. Inputs, let's say 12-bit. So every port is going to have 12 bits now. Say next. Again, we have A, B, C, and O. Our usual signals. O is the only outputs. They are buses, all of them. And again, now we are making them from 11 down to 0 because they are 12 bits. Okay, next. So this is the new component that we've created. We can see all the inputs and the output. And now we are going to have to instantiate the N gate input. Let's get the instantiation template. So first we select the component. View HDL instantiation template. This view instantiation HDL instantiation template, it's inside design utilities. So you have to click on the plus symbol here if it's not expanded. There is one drawback of the way Xilinx generates these instantiation templates. They don't specify the generics. They only specify the port map. So in this case, you'll have to add the generics by hand. So let's copy the component with the port map so far into the new component. I would like to call this one AND gate and bit 1. So we said it's an entity. This entity is going to be found in library work, which is the default library, and it has this port map. Now we also have to mention the value of the parameter of our parameter n, and we do that by saying generic map, and in parentheses we have to specify the value for n. So we say n. We are using the same right arrow just like for the other port instance port assignments, and then we give it a value. In our case is 12. we are not supposed to have semicolon in here when we instantiate. Now let's see how do we connect this A, B, and O for the first component. We need to look at our schematic again. So A was connected to A, B was connected to B, and O was connected to TMP. A, B, and TMP. Okay, so now we have the first AND gate instantiated. Let's copy this one and instantiate the second one as well. So we'll just edit in place. So now we are going to have the AND gate number 2. It's the same name of the component, it's the same number of bits. And now the ports are going to be different. Input A is going to be connected to TMP, input B is going to be connected to C, and output O is going to be connected to O. So A is going to be connected to TMP, B is going to be connected to C, and O is going to be connected to O. Okay, so now we've created our new component. We didn't have any syntax errors. To make sure that we created it correctly, we have to also synthesize it. And to do that, we need to select it, press on the set desktop module, or otherwise you can right click and select from the menu set desktop module. Here say yes. And now we can synthesize our component. Okay, we had some error. Let's see what the problem is. We forgot to declare the internal signal TMP, the one that connects the two components. So let's declare it here, signal TMP. It's standard logic vector 11 down to 0. It's just as wide as the other ones. And let's synthesize it again. So now the synthesis worked okay. Let's see the schematic. So we can see that all the inputs from the top level module are 12-bit. If we look inside, we can see that we have the two AND gates which are instances of component AND gate N bit. Every port has 12 bits, so we specify that the N parameter for this component is 8 bits. And this is our circuit now. So these generics are used to specify the number of input bits. So it's basically a parameter that we can give to the component where we instantiate it. In case we don't mention this parameter, then the default value is going to be used, and the default value is the one that we find in the component itself. It's the one that we put it in here in the component declaration, in the entity for this component. But what if we want to have some kind of constant, so some kind of value that is internal to the component, and we don't want that value to change no matter what? How would we do that? So let's try to modify this design. Let's make a new entity called AND gate with 2 inputs and 1 constant, and every input has 12 bit. Now I'm going to apply a, let's say, different technique. I'm going to actually save this file as a new file. Going to save as. Then I'm going to say the new name of the file that I want. So it's an AND gate with 2 inputs and 1 constant. And every input has 12 bit. We're going to save this. The file is not added automatically to the project, so I need to add it myself. I'm going to select from here, add source. This is the new file that I created. Then this file is going to be added to my work library, and I just click OK. So now if I look in my work library, I'm going to not see it yet in here. And the reason why I don't see it yet is because it has the same name. The component name is the same, like in the other file. So actually I can go here to files and then double click in here to bring the file on top. So now what I need to do is to modify the name of the entity. One easy way to do it is to select the text of the entity name, then type Ctrl-H, and now we can take the name from here, type Ctrl-C, and then replace this one with the new name that we want. So the new name that we want is 2 inputs and 1 constant, and it's 12-bit. And we want to replace this string anywhere where it shows up in the original file. So I say replace next, and you see it was instantaneously changed. Replace next, replace next. You can also do it on top. Now when it's red, it means that we replaced all the possible places. Okay, so now when I save this file, if I go back to my design, I'm going to see also this new component available here. So what I want to do in this component is to have only 2 inputs, and the current third input I want to replace with a constant. So for example, the C is not going to be an input port anymore. I'm taking it from the ports. I want to make it a constant which is internal to this component. I can realize that by creating a constant within the architecture. So between the line where we declare the architecture and begin. Let's say Ctrl-V to paste the value that we had for C in the port declaration. Now we are going to say, instead of signal, we're going to say constant C, and then we're going to say the type of the constant. In this case, is standard logic vector 11 down to 0. Now we also need to give a value to the constant. So as soon as we declare a constant, we also need to assign a value to it. And let's say that the value is it's a hexadecimal number. Let's say it's the hexadecimal value is BAD. Okay, now let's save this. So the value of C is not coming anymore from the outside is not an input port, it's just a constant which has always this value. So let's synthesize this and make sure that it works properly. We select the component name. We click on this button to set it as a top module. Say yes. Now let's synthesize. And then the synthesis worked as well. So this way we've basically hidden one of the inputs inside the component. You can use as constants anything that it's internal to that component, that the users don't need to know about it. Users of that component don't need to know about it. And that's about it. So we discussed about instantiating component. Then we talked about instantiating a component with parameters. In our case, we had one generic. And then we talked also about constants, which are values that are internal to one of to the component itself. It can't be changed from the outside. So I'm going to put the files for this video also in the description of the video on YouTube. And I hope that that I provided you with some useful information. So when you are going to open this file, you are going to have all these top-level components created, and if you want to select one of them to synthesize this one, for example, then first you select it and then you have to make it top level, and then you can synthesize it and whatever. And this trick works to any level. So if you, for example, want to get a regular AND gate with 8 bits per input and make it as top level, that's also possible. So you see, even if it's used by this component, by this entity, we can still make it a top level. And basically we synthesize only this component. Okay, so that's about it.